Welcome! This is your definitive guide to physical training for your GCSE PE exam. We're going to cover everything from the absolute basics of fitness all the way to how you can nail those big 9-mark questions. Okay, let's get right into it. So before we dive into all the different training methods, let's just start with this one fundamental question. It seems pretty simple on the surface, right? But the answer is actually really detailed, and knowing it is absolutely key to your success. To answer that question, we first need to get our heads around the 11 key components of fitness. These are often split into two camps, health-related and skill-related. Honestly, just think of these as the essential ingredients that every single athlete uses. You've got to know these definitions inside and out. First up, a huge health-related one, cardiovascular fitness. This is basically the engine for any endurance athlete. It's all about how well your heart and lungs can get oxygen to your muscles while you're working. It's absolutely vital for someone like a marathon runner who needs to keep a steady pace for, well, a very long time.
Next, we've got muscular strength. Now this is all about producing a single maximum force. Picture a weightlifter doing a clean and jerk, or a rugby player driving with all their might in a scrum. That right there is pure, unadulterated strength. Then there's muscular endurance. This isn't about one big explosive effort. It's about being able to repeat movements over and over again without getting tired. Think about a rower pulling that oar again and again, or a cyclist who's grinding up a long hill. That's muscular endurance.
Flexibility is, well, pretty straightforward. It's the range of movement you have at a joint. Yeah, it's really important for preventing injuries, but for an athlete like a gymnast, having a massive range of motion is what lets them perform those absolutely incredible leaps and tumbles.
And our final health-related component is body composition. This really matters because different sports tend to favor different body types. For athletes like rock climbers or high jumpers, having a lean build with low body fat can be a massive advantage.
Okay, now on to the skill-related components. We're kicking off with agility. Just think of a badminton player or a basketball player. They have to constantly and rapidly change direction, speeding up and slowing down, all while staying in complete control to cover the court.
Balance is just critical for pretty much every sport you can think of. It can be static, like a gymnast holding a pose perfectly still on a beam, or it can be dynamic, like a skier constantly adjusting their body as they fly down a mountain.
Coordination is all about timing and making your movements smooth and efficient. A trambolinist who times their arm and leg movements perfectly to pull off a somersault is just a fantastic example of what incredible coordination looks like.
Right, power. This one is so important. The thing you have to remember is that it's a combination of strength and speed. It's not just about how strong you are, it's about how quickly you can apply that strength. A javelin thrower is the classic example here. They turn all that strength into an explosive, rapid movement to launch that spear.
Reaction time is that tiny sliver of time between seeing something happen and actually moving in response to it. It's what lets a 100-meter sprinter explode out of the blocks the instant the gun goes off, or a boxer dodge a punch that's coming right for them.
And finally, we have speed. This could be the speed of just one part of your body, like a tennis player's lightning-fast serve, or it could be the speed of your whole body, like a footballer sprinting to get on the end of a through ball.
Okay, so we know what the components are. How do we actually improve them? Well, this table gives us a brilliant overview of the main training methods, laying out their pros and their cons. And you'll notice there are always trade-offs. Something like continuous training is super simple and amazing for your cardiovascular fitness, but it can get pretty boring. At the other end of the scale, you've got plyometrics, which is incredible for developing power, but it also carries a much higher risk of injury if you don't do it right. It's all about picking the right tool for the right job.
And hey, we can't forget about fitness classes. Things like yoga and Pilates are just fantastic for working on those components that sometimes get a bit neglected, like flexibility, balance, and core strength, which, by the way, are the foundation for so many other athletic movements.
So, you know the components of fitness and you know the methods to train them. But here's the thing. It's not enough to just do the training. You have to do it at the right intensity. Now we're going to look at how to train smart by understanding training thresholds. This is where you really start to see the big results. The number one rule of training smart is the principle of specificity. All this means is that you have to match your training to the specific demands of your sport. It's just common sense, really. A marathon runner's main tool is continuous training for that endurance, while a shot putter is going to live in the weights room to build strength and power. And a rugby player who needs a bit of everything, sprints, jogs, walks, would get a huge benefit from fartlek training.
But being specific isn't quite enough. To really truly improve, you have to work at the right intensity. And that is where training thresholds come in. These are what makes sure you're pushing your body enough to force it to adapt and get stronger, but not so much that you end up getting injured.
This is your endurance zone. If you want to improve your cardiovascular fitness, you need to keep your heart rate between 60 and 80% of its maximum. This is the sweet spot where your body is using oxygen to produce energy really, really efficiently.
Now, when you need to improve your speed or your power, you've got to push into the anaerobic zone. This is up between 80 and 90% of your max heart rate. Here, your body is working so hard it can't get enough oxygen. You can't stay in this zone for very long, but this is where you make those huge gains in speed.
And the exact same idea applies to weight training. Your goal completely changes the threshold. If you're going for raw strength and power, you lift heavy. We're talking over 70% of your 1-rep max for just a few reps. But if you're training for muscular endurance, you do the complete opposite. You lift lighter weights below 70% for many, many more reps.
Okay, so you're training smart, you're hitting your thresholds, you're being consistent, but what is actually happening inside your body over all those weeks and months? Let's take a look at the amazing long-term adaptations. This is the incredible thing about training. Your body responds to the stress you put on it by adapting. It literally rebuilds itself to be stronger and more efficient. These adaptations are what allow you to progress, to run further, lift heavier, and just push yourself harder than you could before.
And these adaptations are seriously profound. Your bones actually become denser to cope with all the impact. Your muscles get bigger and stronger. That's what hypertrophy is. And internally, your heart, which is a muscle, remember, it literally gets bigger and stronger, and your lungs' ability to take in air increases. Your body just becomes a much, much more efficient machine.
All right, let's bring all of this knowledge together. This is the moment we put it all into practice. I'm going to show you how to take everything we've just covered and use it to build a top-scoring 9-mark answer in your exam.
Here we go. This is a classic example of a 9-mark question. Now, the T word here is evaluate. That's a massive clue. It means you have to weigh up the good points and the bad points. So, let's break down how to structure the perfect response.
Every single answer you write for a question like this needs to be built around these 3 things. The assessment objectives. First, AO1, that's where you just show what you know. Then AO2 is all about applying that knowledge to the specific sport in the question. And finally, AO3 is where the big marks are. It's where you analyze, evaluate, and come to a balanced conclusion.
So, for your AO1 marks, your knowledge marks, you start with the basics. First, define what circuit training is. Then, identify the key components of fitness that a basketball player would need. Things like agility, power, and cardiovascular fitness are all perfect choices here.
Next up, AO2. This is where you apply that knowledge directly to our basketball player. Don't just say it improves agility. You have to explain how. For example, you could suggest including a station with shuttle runs specifically to improve agility. Or you could explain how keeping the rest periods short will keep their heart rate up in that aerobic zone, which will boost their cardiovascular fitness.
And finally, for those big AO3 evaluation marks, you have to weigh things up. Talk about the advantages. Better cardiovascular fitness means they won't be as tired in the final quarter of the game. But then you must discuss the disadvantages. A huge one here is that circuit training just isn't very sport-specific. It doesn't have defenders, it doesn't have teammates, and it doesn't have those split-second decisions you have to make in a real match.
So there you have it. We've covered the components, the methods, the science behind it all, and exactly how to prove you know your stuff in an exam. We've basically given you the complete toolkit. So the final question is really for you. Now that you have this framework, how are you going to apply it to reach your goals? Thanks for watching.